Hi boys, so today I'm just going to run back through that question 1 exam question that you did yesterday, and then we'll be moving on to new chapter. So I'm just going to run through this because this one has a bit of everything in it except the right angle triangles, which I think we're pretty okay on. Okay, so the first part of this question asks us to find the length of BC, which I call x there, okay? So we have to decide now, it's a non-right angle triangle and we're trying to find the length, so we have to decide whether to use the cosine rule or the sine rule, okay? So to use this cosine rule we have to be given two lengths in the angle in between, which we're not given, we're only given one length, and we have to be given three lengths and looking for an angle. So we will not be using the cosine rule for this question for part 1. So we're obviously going to be using the sine rule. We're looking for a length, so it goes on top. So A over sine A, we write out the formula, is equal to B over sine B is equal to C over sine C. Okay, so we fill in what we know. So the length we're looking for here is x. So x over sine, and it's the angle opposite. Okay, so these two go together, so it's 42 degrees is equal to 16 over sine 110. Okay, so again, opposites go together for non-right angle triangles. So then we multiply across by our sine 42 to get rid of our fraction, get x on its own. X is equal to sine 42 by 16 over sine 110. X then is equal to, when we put all that into a calculator, so sine 42 by 16 over sine 110, close your bracket. Okay, so type it in exactly as you have it written there, okay, equals 11.39318,269, asks for two decimal places, so x then is equal to 11.39, and it's in meters, so it's meters, 11.39 meters. Okay, hopefully we could all manage that. So part 2 the question then asks us to find area of the triangle BCD. Okay, so we're asked to find the area of the triangle BCD. So the triangle then BCD, so B up to C over to D, so it's the area of this triangle here. Okay, so it's hence, so we're using the information that we've already found. So we know that the area of a triangle then is equal to a half AB sine C. So we're using two lengths with the angle in between. So our area then is equal to half of A, which is 16, by B, which is the length we just found, 11.39, sine then, and it's the angle in between. So the angle in between then, lads, is this angle here. Okay, so you have this length, okay, so you have these two lengths, so you have to use the angle in between. So then we know that every triangle has 180 degrees. So we put that into the calculator, so 180, take away our 42, take away our 110, and it's 28 degrees. Okay, so it's 28, okay, so sine 28 then. That equals then, we put it all into the calculator, stick in our sine 28, put it all into the calculator then, so 1 over 2, multiply it by 16 by 11.39 by sine 28. So 42.77824888. Question asks for 2 decimal places. So the area then is equal to 42.7, and our 8 there tells us to round up, and it's meters squared. Okay. Okay. So the last part of this question, part B, that was part A, 1 and 2. So part B then asks us to find length of AB. So those two lines just mean the length of AB to 2 decimal places. Okay. Find the length of AB, so this length here, to 2 decimal places. Okay, so find that length there. So again, what are we given? Are we going to use the sine rule or the cosine rule? So the cosine rule is when we're given 2 lengths and the angle in between, and we're looking for the third side, or we're given the 3 lengths and looking for an angle. Okay, so are we given 2 lengths, we're looking for the third length, are we given the angle in between? Okay, so again, we know, we actually are here, we know when we're looking for a length as well, guys, just we don't have these angles, these 2 angles, so we can't use the sine rule. Okay, so we know in a straight line then there is 180 degrees. So we're given 63, take away our 42 equals, I'm going to stick that into the calculator then, we're getting 75 degrees. So this length here is 75. Okay, so we're going to be using the cosine rule, and our cosine rule is, again, it's in the log table, so you don't need to remember, but it's a squared is equal to b squared plus c squared minus 2bc cos a. So the angle out here is the length out here is the angle in here. Okay, so this is the angle we're given. The opposite then is the one that goes out on its own, so that's what we're trying to find. So we're going to call that y. So y squared then is equal to 10 squared plus 16 squared minus 2 by 10 by 16 cos, and our angle is 75 degrees. So y squared then is equal to 10 squared is 100 plus 16 squared is 256. So when you put it into calculator, minus 2 by 10 by 16 is 320 cos 75. Okay, so y squared then is equal to 356 minus 320 cos 75. Y squared is equal to 356. Again, lads, I'm only doing one step at a time. Minus, and then 320 cos 75 is equal to, I'll hit that S3 button, 82.822094443. So y squared is then equal to 356 take away 82.822094443, and we're getting 273.1779, y then is equal to the square root of 273.1779. Y then is equal to the square root of 273.1779 equals, so it's 16.528. 16.528, and the question asks for 2 decimal places, so y is equal to 16.53 meters. Okay, and that is a past exam question, lads, so if you can do that, it should be okay. Alright, so that is a past exam question. So it's not going to get a whole lot harder than that, okay? So hopefully that was okay. So now we're going to go on to a new chapter. Okay, so we're going to go on to chapter 18. We're going on to coordinate geometry of the line. So a lot of you will have remember this from junior cert. Okay, so just the first few things just to note is that any points that lie in here is in the first quadrant, any points that lie in here is the second quadrant, the third quadrant, and the fourth quadrant, so any points in there. Okay, so we have our x-axis. Okay, so our x-axis is always on the horizontal. Okay, our x-axis, and then our y-axis is always on the vertical. Okay, so we have our x-axis and we have our y-axis. Okay, any points that lie in here is in the first quadrant, any points that lie in here is in the second quadrant, the third quadrant, and the fourth quadrant. Okay, so then boys, every point has an x and a y coordinate. Okay, every point has an x and a y coordinate. So x and a y. X and a y. Every point has an x and a y coordinate. Okay, x always comes first. X always comes before y. Okay, so the way I always remember that is x comes first in the alphabet. So we write down x first. Okay, so in our first quadrant, our x's are positive and our y is positive. Okay, our x is positive and our y is positive. In the second quadrant then, our x is negative and our y is positive. Okay, so in the second quadrant, our x's are negative and our y's are positive. In the third quadrant then, our x is negative and our y is negative. And in the fourth quadrant then, our x is positive and our y is negative. Okay, so in that first quadrant they're both positive. In the third quadrant they're both negative. In the second quadrant our x is negative and our y is positive, and in the fourth quadrant then our x is positive and our y is negative. Okay, so now we're going to have a look at plotting some points. So we draw out our axis. So we have our x and we have our y. Okay, so lads, make sure you're using a ruler when you're drawing out your axis. Okay, and now lads, the biggest mistake that I see boys making with this is that your scale. Okay, so if we say that 1 square is 1, then there must be 1 square between each one. Okay, so we've 1 square to 2, another square to 3, another square to 4, another square to 5, another square to 6, another square to 7, another square to 8, and another square to 9. Okay, And the same with our x's. So if we go 1 square to 1, it's 2 squares. And another square to 3, and another square to 4, and so on. Okay? Okay? And the same with the other way. So if we're going out 1 square, so we use the lines of the squares as well, okay, to be our numbers. And I always draw little notches so I know exactly where I'm talking about, okay? So again, so if we've 1 box to 1, we must have 1 box then the other direction to -1, -2, -3, -4, -5, -6, -7, -8, and -9. And then the same this way. So -1, -2, -3, -4, -5, -6, -7, -8, -9. Okay, lads, so if there's 1 box to 1, there must be another box to 2. Okay, if we did 2 boxes to 1, then there'd be another 2 boxes to 2. Okay, the biggest mistake that's made with these is lads take 2 boxes to go out to 1, and then they do 1 box between each. That's not right. Okay, we can't be doing things like that. So if it's 2 boxes out to 1, then it's another 2 boxes to 2. We must keep the same scale. Okay, so I have that's 1 box to 1, so it's another box to 2, another box to 3, another box to 4, another box to 5. Okay, and the same going the other direction. So 1 box to -1, another box to -2, another box to -3. Okay, so the same number of squares have to be between each one. Okay, that's really important. So if I was to plot then 1, 1, okay, so this is my x and this is my y. Okay, so my x and my y. So on my x scale I go to 1, I go out to 1, and I climb 1 because my y is 1. Okay, so there's 1, 1. So if I call that A, that's A. Okay, so if I go to 9, 5, okay, and that's B, I go, my x is first, so on my x-axis I go all the way, I run all the way out to 9, and then my y is 5, so I climb 5. 1, 2, 3, 4, 5. Okay, and that is my B. So the same then, if I have 1, -2, so I go out to 1 on my x-axis, and then it's -2, so I go down 2. My D then is -6, my x is first, so on my x-axis I go all the way out to -6, and then my y is also -6, so I come all the way down to -6. So you can see there, if I go up, I'm at -6 on my x-axis, and if I go straight across then to my y-axis, it's -6. Okay, so the same with my B then. If I come down to my x-axis, I'm at 9, so there's my 9, and if I go across to my y-axis, it's 5. So my point there is 9, 5. So then if I was plotting E there, so it's -5, 7. So on my x-axis, my x comes first, then my y, so I go all the way out to -5 on my x-axis, and it's 7 on my y-axis, so I go climb all the way up to 7. So there's my point, E. Okay, so if I have my point, I come down, it's -5 on the x-axis, and I go across to my y, it's 7. So if I was given this point here and call F, and I was asked what's the coordinates of F, okay, so my x comes first. So if I go up to my x-axis, I'm at 7, and then if I go across my y-axis, then I'm at -7. Okay, so my y is -7, and the coordinates are always in brackets as well. Alright. Okay, so it's 7. If I go up to my x-axis, sorry, it's 7. So my y point, or my x point is 7, and if I go across then to my y-axis, it's -7. So my y is -7. Okay. So hopefully we remember that from Junior Cert. Then we're going to look at finding the distance between 2 points. Okay, so if we're asked to find the difference between R and S, we're given the 2 points, okay? So we're given a formula in log tables to help us do this. Okay, so you don't need to learn it off, it's in the log tables. But if we're wondering where the formula originates from, so I'll just write out the formula there for you first. So this is the formula here, so that's given to us in log tables, it's on page 18. Okay, so it's the square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Okay, so if we're wondering where that originates from, so we're given this, and we're asked to find the distance between 2 points, okay? But if I do this, okay, I now have a right angle triangle. This point here, so this point here then is 5, 2. Okay, and if I have a look at my scale then, see I have 2 boxes out to 1, I have another 2 boxes to 2, another 2 boxes to 3. Then on my y-axis I have 2 boxes to 1, I have another 2 boxes to 2, another 2 boxes to 3. I have 2 boxes down to -1, I have another 2 boxes down to -2. On my x-axis I have 2 boxes out to -1, I have another 2 boxes out to -2. Okay, so my scale is all lined up there, okay? So now from drawing those 2 lines, I now know this is a right angle triangle. Okay? And each 2 squares then is 1 unit, isn't it? So if I count out how many units is from here to here, so it's 1, 2, 3, 4. So that's 4 units, the length there. And going up then, so it's 1, 2, 3. Okay, so now we know the lengths, okay? So if I have a look at that, I know 5 take away 1 is 4. So 5 take away 1 is 4. And on my y's then, 5 take away 2 is 3. Okay, so 5 take away 2 is 3. So I know that in that Pythagoras' theorem is a squared is equal to b squared plus c squared. A squared has to be the hypotenuse, is equal to 3 squared, 4 squared even, plus 3 squared. Okay, so h then is equal to the square root of 4 squared plus 3 squared. Okay, so h is equal to the square root of 4 squared is 16 plus 3 squared is 9. H then is equal to the square root of 25. H then is equal to 5. So our length here is 5. Okay? But if we were to write that, if we were to go back up here and rewrite that here, wouldn't it? The length of h is equal to the square root. So our 4 then, so the 4 was the difference between our x's. So it's x, 5 take away 1. So if we name this x2 and this x1, so it's the difference of our x's to be squared plus the difference in our y's. So it's 5 take away 2 is 3. So y2 minus y1 all to be squared. Okay, so that's to find the difference between 2 points then is really just the Pythagoras' theorem formula. Okay, so that's what it really is there, just written slightly different. So if we look at an example then, just before I give you some questions to do, if we look at an example, so if we are looking for the distance between the points -1, 1 and 20, 21. Okay, so if we're finding the difference between those 2 points. So the first thing we always do is write out the formula. The formula is the distance between A and B, so that's what those 2 lines mean. It's just the distance between A and B is equal to the square root of x2 minus x1 to be squared plus y2 minus y1 all to be squared. Okay, so that's in the log tables on page 18, so you don't need to remember it, you just need to know how to use it. Okay, so the thing I always do, lads, is I label my points. Okay, so I think this is important to make sure we do. So this is our one point and this is another point. Okay, and remember that every point has an x and a y coordinate, an x and a y coordinate. So the x always comes first. So x and y, x and y. Okay, now we have 2 x's, so we need to know the difference between the x's. So that's why we call one x1 and the other x2. Okay, and y1, y2. So that's you need to know the difference between the y's and the x's. That's why it's called x1, y1, x2, y2. Okay, so now we're going to fill in the formula. So always make sure and label those points, boys. You'll be amazed at the amount of people who don't label them and then fill in the formula wrong. Loads of people think, oh, labeling, waste time, I'll go do my formula. But then you're amazed at the amount of people that do not get this right. Okay, and it's fairly straightforward. So then the length of AB is equal to the square root of, open up your bracket, okay, so square root, open up my bracket, x2 then, so what did we label x2? It was 20. Take away x1, so what did we label x1? And it's a minus 1, so I'm just putting it in a little bracket because it's a minus. And it's all to be squared. Plus, open up the bracket, y2, so what did I label y2? It's 21 minus y1, so what did I label y1? And then it says close my bracket and square it. Okay, so AB then is equal to the square root of 20 minus minus by minus becomes a plus 1 to be squared plus 20 take away 1, 21 take away 1 is 20 to be squared. Okay, so AB then is equal to the square root of 20 plus 1 is 21 to be squared plus 20 to be squared. AB is equal to the square root, so 21 squared then (441) plus 20 squared is 400. AB is equal to 441 plus 400 441 plus 400 is equal to 8 square root of 841, which then is equal to the length of AB is equal to, so the square root then of 841 equals 29 units. So the distance between the 2 points then is 29. Okay. So that should be okay for you then, boys. Alright. So what did I do there? The first thing is I wrote out my formula. Okay, so the distance between A and B is equal to square root of x2 minus x1 all to be squared plus y2 minus y1 all to be squared. Okay, then I labelled my points. Okay, so I had an x and a y, an x and a y, and then I labelled them x1, y1, x2, y2. Okay, so that's just another difference between the two x's. So then I subbed in for my formula. So my formula says the square root of, open up my bracket, x2, so instead of my x2 I put in what I labelled x2, which is 20, minus then, brought down, x1. So what did I label x1? It was minus 1. So instead of x1, put in a minus 1, put them in brackets there because it's a minus. And it told me to close my bracket and square it, so I closed my bracket and squared it. Plus, open up my bracket, y2 then, what did I label y2? 21, minus y1, so what did I label y1? 1, so I put in my 1. Close my bracket, square. Okay, so AB then is equal to 20 minus by minus is a plus 1, all to be squared, plus 20 minus 1, or 21 minus 1 is 20, and it says to square it. So AB then is equal to the square root of 20 plus 1 is 21 to be squared, plus 20 to be squared. Okay, so AB then is equal to 21 squared, open up my square root, 21 squared is 441, plus 20 squared is 400. AB then is equal to the square root of 441 plus 400 is 841. AB then, the length of AB is equal to the square root of 841. When I put that into my calculator, I got 29. So the length is 29 units. Okay? So then, boys, what I want you to do then today is page 548 plus 549, exercise 18.1, questions 1, 6, and 8. So question 1, 6, and 8. Okay? So lads, it's really important that we're doing this work. Alright, it's not midterm yet, it's midterm next week. So put in the effort now this week and get all this work done. Okay? So get going there. Get those done and submitted. Okay? Any questions? Let us know. Messages on Teams. Okay? So if you have any questions, you're stuck, or you want a hand or anything like that, just let us know. Okay? Just messages in Teams. Alright? So get going on those then and make a really big effort now this week before next week. Alright? We have a break next week, so put in a big effort this week. Okay? Thanks, boys, and I will talk to you tomorrow. Okay?